Hello friends, continuing with Coulomb's law, we come to vectorial expression of Coulomb's law. How we can write vectorial expression of Coulomb's law? We take up case by case. First we take up first case, case 1. Consider 2-point electric charges Q1 and Q2 with their position vectors R1 and R2 respectively, as shown in diagram A. This is diagram A. The force on charge Q1 due to Q2 is equal to, say, F12. How we write? F12 is equal to K naught Q1 Q2 by R21 square into unit vector R21, where vector R2 plus vector R21 is equal to vector R1. So this is using triangle law of vectors. We write this expression, or we can write R21 vector is equal to R1 vector minus R2 vector. So this is how when we calculate force on charge Q1 due to Q2. Now we go to second case, case 2, when we calculate force on charge Q2 due to Q1. Now consider again the same 2-point electric charges Q1 and Q2 with their position vector R1 and R2 respectively, as shown in figure A, diagram A. The force on charge Q2 due to Q1 is equal to, say, F21. F21 is equal to K naught Q2 into Q1 divided by R12 square into unit vector R12, where R1 vector R1 plus vector R12 is equal to vector R2, or vector R12 is equal to vector R2 minus vector R1. So this is how we can express the force on one charge due to another charge and in vectorial form. Okay, so you should practice this, how to write, learn the sequence of the symbols used here. If F21 is there, then unit vector is R12. Charges are similar. If charges are opposite, then it would be same. F21, then unit vector will also be F21, R21. Okay. Yeah, this practice you have to do, and quickly you should be able to write. Otherwise, you won't be able to solve the numerical problems. So this practice is needed for similar charges as well as for opposite charges. Now we come to Newton's third law of motion from Coulomb's law, or we can say Newton's third law of motion is hidden in Coulomb's law. How we can derive Newton's third law of motion from Coulomb's law? Let us see. Now, what is Newton's third law of motion? To every action force there is a reaction force. Okay, so this is the statement of Newton's third law of motion. Now proof how we can derive third law from Coulomb's law. Consider 2-point electric charges Q1 and Q2. Q1 and Q2 with their position vector R1 and R2 respectively, as shown in figure A and B as well. So this is figure B. Now force on charge Q2 due to Q1. Force on charge Q2 due to Q1 is F21 is equal to K naught Q2 Q1 divided by R12 into unit vector R12, or we can write it as equal to K naught Q2 Q1 divided by R21 square into minus R12. Okay, when we add minus, then the suffix would change because direction becomes opposite. or we can write F21 is equal to K naught Q2 Q1 divided by R12 square into R21 R21. Okay. Now K naught Q2 Q1 divided by R21 square into R21 unit vector, it is equal to F12. You can see above in the previous slide the expression of F12. So we write minus separately and F12 separately. So F21 is equal to minus F12. It is also a vector quantity. Arrow is not there. Here you can put arrow on it. Thus F21 is equal and opposite to F12. F21 is equal and opposite to F12 and is the reaction force. F21 is the action force, then F12 is the reaction force. Hence Newton's third law of motion is hidden into Coulomb's law. This is how we can say Newton's third law of motion is hidden into Coulomb's law. Now significance of Coulomb's law. Significance, how we can say the significance of Coulomb's law. First point, the Coulombian force always acts along the line joining the charges. First point about significance. Second point, Coulomb's law obeys Newton's third law of motion. Third, Coulomb's law conveys the idea of central force. That is, the force acts from center to center of the charges involved. So these 3 points you have to mention about significance of Coulomb's law. I repeat, the Coulombian force always acts along the line joining the charges. Number 2, Coulomb's law obeys Newton's third law of motion. Number 3, Coulomb's law conveys the idea of central force. That is, force acts from center to center of the charges involved. Now assignment 1-2 continued. Question number 14. Express Coulomb's law for the two charges plus Q1 and minus Q2 with their position vector R1 and R2 respectively in vectorial form. Question number 15. Draw Newton's third law of motion from Coulomb's law. Now, after understanding about the vectorial expression of Coulomb's law and its significance, we come to another principle titled as superposition principle of forces. What is the statement of superposition principle of forces? When two or more charges exert force simultaneously on a given charge, the total force experienced by that charge is equal to the linear vector sum of the forces that the various charges would exert individually on that charge. Okay, I repeat, when two or more charges exert force simultaneously on a given charge, the total force experienced by that charge is equal to the linear vector sum. This is linear vector sum to be noted, the linear vector sum of the forces that the various charges would exert individually on that charge. Here in the diagram you can see there are charges Q1, Q2, Q3, Qi, Qn. So this is Q1, this is Q2, this is Q3, this is Qi and this is Qn. Their position vectors are R1, R2, R3, Ri and Rn respectively, as we have shown. The force due to Q2 is F12, due to Q3 is F13, due to Qi is F1i and due to n is Qn is F1n. So this is how the diagram is. You have to understand and you have to write the expressions for forces due to Q2, Q3, Qi and Qn and so on. Now let us see how we can write the expressions. Now first we develop physical situation. To derive an article, always we first have physical situation. Consider n point electric charges Q1, Q2, Q3, Qi, Qn with lying in any region of space with their position vectors r1, r2, r3, ri, rn respectively as shown in diagram. So this is Q1 with position vector r1, this is Q2 with position vector r2, this is Q3 with position vector r3, this is Qi with position vector ri, this is Qn with position vector rn. Okay. Now suppose total force on Q1 is to be calculated. Total force on Q1 is to be calculated. Then according to statement, total force on Q1 due to Q1, Q2, Q3, Qi and Qn would be say F equal to F12, F plus F13 plus F14 plus F1n. Okay. So this will be the linear vector sum of all the forces that are exerted on Q1 individually by Q2, Q3, Qi, Qn, etc. Now we write the expression separately. Now force on Q1 due to Q2 is equal to say F12 is equal to K naught Q1 Q2 divided by R21 square into R21 unit vector. Similarly, force on Q1 due to Q3 is equal to F13 equal to K naught Q1 Q3 divided by R31 square into R31 cap. Similarly, force on charge Q1 due to Qi is equal to F1i equal to K naught Q1 Qi divided by Ri1 square into Ri1 cap. And force on charge Q1 due to Qn is equal to F1n is equal to K naught Q1 Qn divided by Rn1 square into unit vector Rn1. Total force on Q1 due to all other charges would be say F equal to F12 plus F13 plus F14 plus so on F1i plus so on F1n. And now we add up all of them. Now on adding we get the linear vector sum. The vectorial expressions are there, so we add them. So it will be addition. The addition will be giving us linear vector sum. Now total force F. Total force F is equal to K naught Q1 Q2 by R1 square into R21 cap. First K naught Q1 Q2 divided by R21 square into R21 cap plus K naught Q1 Q2 by R31 cap 31 square into R31 cap plus so on K naught Q1 Qi divided by Ri1 square into Ri1 cap plus so on K naught Q1 Q2 Qn K naught Q1 Qn divided by Rni square into Rni cap. And instead of writing the so lengthy expression, we write summation. So F is equal to summation K naught Q1 Qi divided by Ri1 square into Ri1 cap, summation I equal to 2 to I equal to n. I cannot be equal to 1 because we are calculating the force on charge Q1. So this is a total force acting on Q1 due to the charges Q2, Q3, Qi, Qn. Okay. So, this is a simplified expression for the total force. Now, assignment. Most important part is the assignment 1.2 continued. Question number 16. State superposition principle of forces due to electric charges and derive an expression for the total force acting on a given charge in a group of charges. Now, question number 17. Three charges lie along x-axis as shown in the figure. The positive charge plus Q1 is equal to 30 microcoulomb is at 2 meter, and the positive charge plus Q2 is equal to 12 microcoulomb is at origin, where must a negative charge Q3 be placed on the x-axis such that resultant force on it is 0. Okay. So, you have to calculate the distance of Q3 from origin. Now, question number 18. This is very important numerical. I suppose everyone has to learn about it because it is a competitive problem. The two identical point charges of magnitude Q are kept at a distance r from each other. A third negative charge is placed on the line joining the above two charges such that all the three charges are in equilibrium. Calculate magnitude and location of the third charge. So, I give you a hint how you should do it. First, draw the diagram, then write down forces F13, F13 and F12. Then you write F32 or F23. So, whatever is the sequence that you develop, to write the expressions in vectorial form and then find out the solution. This is how you are to solve the problem. Now, assignment 1.2 continued. Question number 19. Two similar and equally charged identical spheres A and B repel each other with a force of 2 into 10 raised to power 5 Newton. A third identical uncharged sphere is touched with a and then placed at the midpoint between A and B. Here A is capital. Okay. So, you can correct it. Calculate the net electric force on C. Okay. Calculate the net electric force on charge C, sphere C, how it experiences the force. Now, answer would be, I think, 2 into 10 raised to power 5 Newton. Resultant force would be 2 into 10 raised to power 5 Newton. It is in the textbook, you can see their answers. Okay. Now, thank you so much.